everybody. In today's video, we're going to be solving multi-step equations. More specifically, we're going to be solving equations with variables on both sides, like this one. Okay, so there are a couple of things to think about when you're solving multi-step equations, and that's the following. First thing, you want to combine the x terms together on one side and the constant terms on the other side. If we look carefully here, we've got 7x on the left side of the equation, and you've got 4x on the right side, and you have 10, which is a constant on the left side, and a 22, another constant, on the right side. Now, to solve an equation, the goal is to figure out the x. So you want to combine the x terms together and the constant terms together. All right. Now, you could go 4 different ways in this situation. You could move the 7x where the 4x, move the 22 to the 10, or you could move the 4x to the 7, 10 to the 22, and vice versa. Now, what we're going to do is we're going to try and avoid dealing with any negative terms. So to do that, you want to see which term is the largest. In this case, the 7x is bigger than the 4x, so it makes sense to move the 4x to where the 7x is, and the 10 is smaller than the 22, so it would make sense to move the 10 over to where the 22 is. Now you want to do this because when you transfer terms from one side of the equation to the other side, you were using the opposite operation or the opposite value. So if you've got a positive term and you're going to move it over, that's going to become a negative term on the other side. Okay, so with that in mind, let's go ahead and get started. So I'm going to put a few dots here to kind of show the center of the equation where the equal sign is. All right, so we're going to start, let's say we're going to go ahead and move over the 4x to where the 7x is. Now, because that's a positive 4x, you want to subtract it. Whatever you do to one side of the equation, you have to do it to the other side so the equation remains balanced. All right, this is the balancing method we're using here. And what we just did here, this is known as the subtraction property of equality. We subtracted a term on both sides of the equation. Now, what that accomplishes, it cancels the 4x term on this side. And here you combine the opposite value with the 7x, which will give us 3x. Now, because we didn't do anything with the 10 or the 22, we're simply going to bring them down with the operation sign. So plus 10 here. The equal sign comes down right on the dotted line, and the 22 comes down on this side. Now, we combine the x terms, so now we have to move over the constant term, the 10. Remember, the goal is to separate the x terms on one side and the number terms on the other side. So here, since the 10 has an addition sign and it's positive, we're going to subtract it. Whatever we do to this side, we have to do to this side. Okay? The 10s on this side will cancel because they're the opposites of each other, and 22 minus 10 will give us the 12 here. We're going to bring down the 3x on this side, because we didn't do anything to that, so it comes down. Now the final goal is to figure out the x. Since the x has the coefficient of 3, and if you recall, coefficients and variables multiply, so we have to do the opposite operation. The inverse operation of multiplication is division. So you always want to divide by the coefficient of the variable you're solving for. So here we're going to divide by the 3 on both sides, leaving us with the final answer for the variable x equal to 4. The 2 3's cancel it into a whole, and the reason why we don't write a 1 here is because 1 times x is simply just x, so you leave it as a variable on its own. Okay, so again, what we did here is we moved the x terms to the left side of the equation and the numerical terms, aka the constants, to the right side of the equation, giving us the final answer. All right, let's take a look at another equation that's very similar here. All right, now feel free to pause the video right here if you want to give it a try on your own. Remember, the goal is to move the variable terms on one side and the constant terms on the other side. Now the variable terms are usually referred to as the algebraic terms. Okay, now looking at this, which side would you think would make more sense to move the y terms? Do you want to move them to the right side or to the left side, and vice versa? Where do you want to have your constant terms? Do you want them on the left side or on the right side? Well, there is a good way to figure this out. It's not always going to be useful, but in this case it is. You look at the bigger positive terms. Okay, if you look at the y terms, the 7y is the bigger term than the 2y, and it's a positive and it's on the right. So it would make more sense to move over the 2y to where the 7y is, and vice versa. It makes more sense to move the 15 to where the 30 is. So in this case, we're going to move the y terms to the right side of the equation, moving the constant terms to the left side. So let's go ahead. I'm going to draw the dotted line. You don't need to do the dotted line here, but it is a good way to kind of keep track of the two sides of the equation. So I'm going to start with the 2y. You can start with the 15. There's nothing wrong with that, but I'm going to start with the 2y. Since the 2y is subtracting the 30, you got to do the opposite operation underneath it, so we're going to add it. Again, anytime you want to move terms from one side of the equation to the other side, you have to do the inverse operation. If it's a subtraction, you have to add it. If it was addition, you would have to subtract it. So here we're adding plus 2y under the 2y and another plus 2y under the 7. What we do to one side, we have to do to the other side of the equation to keep the equation balanced. And the dotted line allows you to see both sides of the equation. So underneath that, we're going to write the final answers, or the resulting answers. So here I'm going to get 9y minus 15. Nothing happened to that, so you simply bring it down. We bring down the equal sign here. The subtraction by 2y and the addition by 2y, you can think of them as a negative and a positive. They're opposites, so they cancel off into a 0. We do not need to write a 0 here because we have a 30 to bring down, so the 30 comes down. Okay, so we combine the y terms on the right side. Now it's the turn to move the 15 to where the 30 is on the left side. To move over the 15, you look at the operation. Since it's subtracting, you gotta add underneath it. And whatever you do to one side, we gotta do to the other side. 15s will cancel here, leaving us with a 9y on the right side of the equation, equal to 30 plus 15 will give us the 45 on the left side. Okay, we're almost there. We have to remove the coefficient next to the y, because remember, the goal is to isolate the variable, meaning leave the variable all alone. When that happens, you will figure out the value of the variable. So here we have to remove the y, and since we have to remove the 9, and since the 9 is multiplying the y, we have to divide both sides by 9. Bring down the equal sign. Now 9 divided by 9 turns into a whole 1, and 1 times y is simply just y, equal 45 divided by 9 will give us 5. So this equation is telling us that 5 is equal to y, or y is equal to 5. And that's the final answer. All right, let's move on to the next slide. Again, feel free to pause this at this point if you want to give it a try on your own. Now, looking at this equation, what do you notice? We got one additional variable term. Now there is a 5b on this side and a 3b, and you got a 4b on the other side. Okay, as you probably have guessed, it would make more sense to move the b terms on this side, on left side, since you have two of them already here, and move the 8, the constant term, where the 16 is, on that side. Now, here's one mistake that a lot of people make in the beginning when they're first starting to learn how to solve multi-step equations. When they see a 5b and a 3b, they think of it as they have to do the balancing method. Here's what I mean. Instead of simply combining the like terms, they would see addition here and they would subtract 3b under the 3b as well as the 5b, like so. At first glance, this might look like the balancing method, but there is a problem. If you look over here, the equal sign is not in between the 5b and the 3b because they're on the same side. So doing the balancing method only on one side of the equation will not keep this equation balanced. Okay, this side will have 6b less than this, meaning we're reducing this side of the equation by 6b because you're subtracting 3b twice on the same side. So you can think of this side being a lot less than this side now. Okay, so how do we combine terms, like terms that are on the same side? Well, let's think about it. What an equation is, it's literally two expressions, one on the left side and one on the right side. All right, and because they're just regular algebraic expressions, you can combine the like terms as if this was a regular expression, meaning you can, in this case, add 5b with 3b because they're like terms and they're on the same side. You do not need to change the operations underneath it because we're not transferring them over to the other side. Okay, now to avoid any further confusion, what I'm going to do is I'm going to do the algebraic terms last. I'm simply going to start by moving over the 8 to where the 16 is so that it becomes a little easier to do. Since the 8 has addition in front of it, I'm going to subtract it underneath it, and then the other 8 would have to go under the 16, putting minus 8 on both sides so that the equation stays equal. The 8s on this side will cancel. On this side, we'll simply get 8. Now, because 16 is the greater absolute value, taking away 8 will give you a positive 8, so the addition stays. 4b comes down. We didn't do anything to that. Equal sign comes down. Now, on this side, we remove the 8, we cancel the 8, so you're literally left with 5b plus 3b. So I'm just going to write 5b plus 3b. Now, if you're pretty advanced, you could have added this already and given up, and we would have gotten 8b here, but I'm gonna go ahead and not do that step yet. I'm gonna do it underneath it. As you can see, 5b and 3b are like terms and they're on the same side of the equation, so you simply add them together without subtracting anything. Okay, so underneath it we're gonna get 8b. Bring down the equal sign, 4b plus 8 on this side. Now we got an 8b here and a 4b here. Well, it makes sense to move the b's on the same side. Since 8b is greater and it's on the left, I'm going to go ahead and move over the 4b to this side. Because it's a positive 4b, I'm going to subtract. I'll put a negative 4b underneath it. Whatever I do to this side, I'm going to do to this side. Okay, now 8b minus 4b will give us another 4b. Bring down the equal sign. The 4b's on this side cancel, leaving us with a positive 8. Final step, we have a coefficient of 4, so we have to divide both sides by 4. Therefore, b will be equal to 8 divided by 4 is 2. All right, because these 2 canceled out into 1b, or simply just b. Okay. Moving on to the next slide. All right, again, this is quite similar to the one we just did. So feel free to pause the video here so you can give it a try on your own. All right, now let's think. Which side would make sense to move the a terms? Well, you have two a terms on the right side and one on this side. So it would make sense to move every a term on this side, which means that the 15 we want to move to the left side where the 45 is. Since the 15 is adding, I'm going to go ahead and subtract it. All right, whatever I do to this side, I'm going to go ahead and do to this side. Right, so that's minus 15 on both sides. Now 45 minus 15 will give us 30. We did not do anything to minus 6a, so we simply bring that down. Now I didn't do the dotted line here, so I'm going to go ahead and do that and bring down the equal sign right where the dotted line is. 9a, nothing happened to that, so I bring it down. The 15 minus 15, that canceled out, leaving us with minus 5a. So I'm going to bring that down with the subtraction in the middle. Okay, now I'm going to go ahead and think about this. So if you look here, you have 9a minus 5a. They are like terms and they're on the same side of the equation, meaning you don't need to do any balancing method here to combine these two. You just simply subtract 9a minus 5a, giving us 4a underneath it, equal to, on this side, we're going to get the same thing because we didn't do anything to it, so we just simply bring it down. All right, final step. Since the 30 is here and the 4a is all alone, it would make more sense to move over the 6a. Also because 6a has a subtraction sign, so if I move it over, it will become a positive term, or it will get the addition sign here. So I'm going to add 6a to both sides. All right, now the 6a will cancel with the 6a on this side, giving us 10a on this side. The 30 will come down as is, and we're one step closer to getting the final answer. Over here, we're going to be dividing by 10 on both sides because the 10 is the coefficient of the a, canceling the 10, giving us 3 equal to a. And that's the answer for a. All right. Okay, let's go ahead and look at our last example. Now, up to this point, I've been showing you answers that are positives for the variables, but that's not always going to be the case. In the following scenario, we're going to get a negative answer, and that does happen quite often, especially when you advance further and further into algebra. Okay, so looking at this example, actually, if you want to give it a go on your own, feel free to pause. All right. So let's think about this. Which side would make more sense to move the z terms or the algebraic terms? Well, as you probably have guessed, since you have 2 on this side, I'm going to move everything that's a variable term on this side. Now, because the negative 3z minus 4z are both algebraic terms and they don't have any constants around them, I'm going to go ahead and combine them as is. Again, I don't need to do the balancing method because these two terms are like terms and they're on the same side. So here, I'm simply going to subtract negative 3z with 4z. Now, if you are not very good at subtracting integers, what you could do is you could use the number line and focus on the coefficient, the negative 3 and the 4. So you can start at the negative 3 here. Now, what's happening to the negative 3? Well, you're going to take away 4 from the negative 3, which means on the number line, if we recall, positives on the right, negatives are on the left. Since you're taking away 4 from it, the negative 3 is going to lose 4 more values, 1, 2, 3, 4, and you're going to end up at negative 7. So the answer for this will be negative 7z, okay, equal to, I didn't do anything to this side, so I'm simply going to bring 2z plus 36. All right, now our final step. We have the negative 7z and the 2z over here. Now you could try and move over the 7z where the 2z is, but then you're gonna be left with 0 on this side of the equation. So in this case, we cannot avoid the negative sign. So I'm going to go ahead and move over the 2z to where the 7z is. So the 36, the constant, is left alone, and I got the z terms on the left side here. So I'm going to go ahead and do minus 2z and minus 2z under the 7z. All right. Now these two, since they both have a negative sign, think of it as adding two negatives together, giving us a negative 9z equal to, now this 2z here is a positive and this is a negative, they're opposites, so they do subtract, leaving us with the 36 all alone. Now here we're going to divide by the coefficient. Now this coefficient is a negative, so when you divide, you don't divide by positive 9, we're going to divide by a negative 9. All right, because you want to eliminate not just the coefficient 9, but also its negative value. And whatever I do to the left, I got to do to the right. I'm going to divide this side by a negative 9 as well, leaving us with z equal to, now 36 divided by 9 is 4, but since the 9 is a negative, positive divided by negative, we get a negative result, so it's a negative 4. And that's the final answer. All right, so the main takeaways of this lesson are: you want to move the algebraic terms to one side of the equation and the constant terms, aka numerical terms, to the other side. What that will accomplish, it will leave the variable all alone in the end on one side and a numerical answer on the other side, giving you the final answer for that variable. All right, if you enjoyed this video, please make sure to like, subscribe, as well as comment with any ideas and any suggestions that I can use in a future video. Thank you so much and have a good day.